Alright, so welcome back. Here's another problem. And what's the first thing we do when we look at problems is we look at the numbers, right? 800 psia, 96% quality saturated steam. And I got a 20 psia here. Alright. Those look good, nothing tricking us. So this problem looks okay. A heat up and pressurization of the reactor coolant system, RCS, is in progress following a maintenance shutdown. RCS pressure is 800 pounds absolute with steam bubble, 96% quality saturated steam in the pressurizer. Pressurizer power operated relief valve, or PORV, tailpipe temperature has been steadily rising. PORV downstream pressure is 20 psia. Which of the following will be the approximate PORV tailpipe temperature and phase of the escaping fluid if a PORV is leaking by? Alright, so this is one that historically everybody just goes to the Moyer diagram to solve, but I don't like the Moyer diagram and I don't recommend using it because you get nervous and you mess it up. So we'll do it the hard way with steam tables. Alright, so the first thing we got to see here is RCS pressure is 800 pounds, 800 psia, and that's pressurizer. And it's saturated, but the quality is only 0.96. So, and pressure of the tailpiece is going to be equal to 20 psia. So we got to ask ourselves now, what does this matter that it's 96% quality? And we know what that means, right? That means that a temperature entropy diagram will look like this. Here's an isotherm. So there's saturation temperature right there. So what we're saying is that the steam is somehow not quite to saturation steam, but 96% of the way there is pretty much there. So I tell you what, since we're doing these problems, we'll do it both ways. So we'll do method 1. So assume they don't know what they're talking about. And quality is equal to 1, or 100% quality. So we're going to assume that the quality is going to be right out here. And say, you know what, that's just margin of error right there. No big deal. And then we'll do method 2. And quality will equal 0.96. Okay, and I'll change color so everybody can see. Alright, so method 1. So PSAT equals 800 psia. Now we're going to say quality equals 100% steam. So now we have to find what? What are we looking for? We're looking for the enthalpy, right? Enthalpy at 800 psia is going to be equal to the steam enthalpy at 800 psia because the quality is there. So we're going to look that up in the superheated table. And 800 psia is on page 19 at the bottom. I'm using table 3 like I always do because it works good for me. So I can see from the second column, well, first I can see that saturation temperature is 518.27 degrees. And saturated steam enthalpy is 1199.3. 1199.3 BTUs per pounds mass. Now, okay, so, and we also know that that's going to be enthalpy of the tailpiece. So the tailpiece is at 20 psia. So now we got to ask ourselves, what is the state of this steam? Alright, so HF, the saturated water enthalpy for 20 psia, is on page 15. And at 20 psia, there's going to be a Tsat 20 psia of 227 degrees. And I'm also going to see that the enthalpy of saturated water is going to be 196.25 BTUs per pound mass. And the steam enthalpy for 20 psia is going to be 1156.2 BTUs per pound mass. All right. That's also going to tell me that the HFG, the difference, the span, if you will, is going to be 1156.2 minus 196.25 BTUs per pound mass. So I'll calculate that real quick. Minus 196.25. 959.95. 959.95 BTUs per pound mass. Okay. Although, you know what? I didn't need to do that, but whatever. We can see that 1199 is way more than 1156. So we can tell, since enthalpy of the tailpipe at 1199 BTUs per pound mass is greater than enthalpy of saturated steam of, and that is at 1156 BTUs per pound mass. Superheat, definitely. How much superheat? Well, on 1199 pounds, I'm in the page 15. I'm on 20 pounds absolute pressure, and I'm looking at enthalpies. So I know saturation temperature is 227. So I go up to 240. That's superheated, right? And enthalpy of superheat, 240 degrees. It's going to be equal to 1162. Enthalpy superheat of 280 degrees, 1181. All right, so we're more than 280. And look at that, enthalpy at 320 degrees is going to equal 1201. So this I'm going to say the answer to method 1 superheated steam at approximately 320 degrees. All right, so now let's change our ink color and we'll do method 2. Sorry. Excuse me. In method 2. And remember, method 2, we were going to say, well, yeah, we got saturated steam at 800 psia, but let's see. Oh, we got a 96% quality. We got a quality issue we got to take care of. So now we have to find the enthalpy at 800 pounds, 96%. Now that is going to equal the HF, or the HF, at 800 psia plus 0.96 times H sub G at 800 psia minus H sub F at 800 pounds. Now, finding those, we got to go to page, again, 19. We're on a superheated steam scale. And I'm going to say that that is 509.83 plus 0.96 times 1199.3 minus 509.83. All of this is going to be in BTUs per pound mass. And let me calculate that number real quick. That is going to be 509.83 plus 0.96 times, open parenthesis, 1199.3 minus 509.83. 1171.72. That's going to be the enthalpy, 800 pound steam with a 96% quality factor. Now that's also going to be the enthalpy of the tailpiece. So now compare that to the tailpiece enthalpy up here with method 1, which was 1199. So you had about a 20 BTU difference. Okay. Well, we will go ahead and carry on with the problem, see if we get a better an answer for temperature. All right, so the HF. So remember, we're going down to 20 psia with an enthalpy of 1171.72. Well, the saturated water from page 15, the saturated water enthalpy is 196.25, and that of course is in BTUs per pound's mass. And saturated steam for 20 psia is going to be 1156.2 BTUs per pound mass. I know I already did that, but that was an accident. So we are superheated because since enthalpy of the tailpiece is greater than enthalpy G at 20 pounds, superheat. So how superheated are we? Okay, so page 15, saturated steam tables. We're on 20 psia. If you go down, and we are at enthalpy tailpipe equals 1171.72. So we start looking at temperatures and finding the enthalpy this will fit in. So I think we said it before, enthalpy of 20 pounds and 240 degrees is equal to 1162 BTUs pound mass, and the enthalpy at 20 psia for 280 is equal to 1181 BTUs per pound's mass. So look at that, we're right in the middle there. So we're right in the middle enthalpy wise of 1162 and 1181. And that means the temperature is right in the middle between 240 and 280. So I'm going to say the method 2 answer is defined as superheated steam with a temperature approximately 260 degrees Fahrenheit. Now, which answer is good? So I got one answer of superheated steam about 320 and one answer superheated steam about 260. What are our choices? 228, 228, 258, and 258. Well, that should be a dead giveaway right there. I'm definitely not at 228 because at 20 pounds, the saturation pressure temperature is 227.92 degrees. Can't be at 228 and superheated to any very good degree. That should have told me first off. So I guess you could look up the saturation temperature and cancel out two numbers if you were that smart. I'm not. I know we have superheated. I know we have 258. We are definitely not saturated in either method 1 or method 2. So I know I'm superheated. I know I'm at 258 degrees Fahrenheit. And that is the answer. So hey, thanks again for listening and watching. And that is all I have to say to you people. Goodbye.